Hello friends, in this video I am going to show you two examples based on the theory of Fourier transformation, the mother equation of Fourier transformation, whatever you have studied in your theory course of this Fourier transformation. Okay, so let's start. The first example is you have to find the Fourier transformation of this signal. This is f of t, t means time, okay, and it is defined as e to the power minus at from t equal to 0 to t equal to capital T, and from capital T equal to capital T to t is equal to infinite, the value of f of t is 0. Similarly, from minus infinite to t equal to 0, the value of f of t is 0. You have to calculate the Fourier transformation of this signal. So the signal is basically from 0 to capital T, the f of t is e to the power minus at, that is nothing but decreasing exponential signal. So we have to calculate the Fourier transformation of this signal. So we all know that f of omega equal to integration minus infinite to infinite f of t e to the power minus j omega t dt. This is the mother equation of Fourier transformation. This is valid when the signal f of t is absolutely integrable from minus infinite to infinite, and it is clear that this signal is absolutely integrable, so that obviously we can use this formula and we can make Fourier transformation. So f of omega equal to, see here the limit is from minus infinite to infinite, but from minus infinite to 0, as f of t is 0, and from capital T to t small t equal to infinite, the f of t is 0. So that basically we have to do integration from t equal to 0 to small t equal to capital T. Clear? In that region, the the f of t is e to the power minus at, so that I have written here integration 0 to t e to the power minus at into e to the power minus j omega t dt. Just you have to integrate this, that is equal to integration 0 to t e to the power minus of j omega plus a into t dt. Okay, and e to the power minus of at integration you all know, that is e to the power minus at by minus a. Then you put this integration, put the limits, upper limits and lower limits, and you will get the answer as 1 minus e to the power minus of j omega plus a into capital T by j omega plus a. This is the Fourier transformation of this signal. Okay, I hope it is clear to you. Now next example is we have to calculate the Fourier transformation of this signal, which is nothing but from t equal to small t equal to 0 to small t equal to capital T. The signal is increasing exponential, that is e to the power at, and small t equal to infinite to small t equal to 0, the value of f of t is 0. Similarly, from small t equal to capital T to small t equal to infinite, the value of f of t is 0. We have to calculate the Fourier transformation of this signal. So the same method that we know that f of omega equal to integration minus infinite to infinite f of t e to the power minus j omega t dt, but we no need to integrate from minus infinite to infinite, because from minus infinite to 0 the f of t is 0, and from t to infinite the f of t is 0. So that basically we have to integrate from 0 to t, so that f of omega equal to integration 0 to t, the f of t is e to the power at in 0 to t, so that I have substituted e to the power at instead of f of t, and we get integration 0 to t e to the power at into e to the power minus of j omega t dt is equal to integration 0 to t e to the power minus of j omega minus a. Here small t will be there, sorry for this mistake, here one small t will be there, and it is dt, and in by integration you will get 1 minus e to the power minus of j omega minus a into capital T by j omega minus a. I hope it is clear. Just simple integration. You all know that the integration of e to the power minus of at is e to the power minus at by minus a, and then you substitute the lower limit and upper limit, and you will get this expression. Okay, this is the Fourier transformation of this signal f of t. Clear? This is all for my this video. Thank you for watching. I will continue in my next video. Thank you.